Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers transformations. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Okay, this shape is rotated 90 degrees clockwise about point A and then enlarged by a scale factor of -2 centre B. I need to draw the final shape on the diagram. So, taking our triangle and first rotating it 90 degrees clockwise about A. So this point here, if I go 90 degrees clockwise about A, is going to end up there. This point is 1, 2, 3 units to the left of A, so it's going to end up 3 units above. 1, 2, 3, it's going to end up there. And then finally this point down here is 1, 2, 3 units below and 3 units to the left of A. So rotating it 90 degrees, it's going to be 3 units to the left and 3 units up. It's going to be there. So our shape then, intermediate shape, is going to be here. Okay, then the next thing I need to do is enlarge it by a scale factor of -2 centre B. Now a scale factor of -2 means each point is going to appear twice as far from the centre of enlargement on the opposite side. So taking this point here first off, it's 1 unit away from the centre of enlargement, so its image is going to be 2 units on the opposite side. It's going to be there. The second point is 3 units away to start off with from the centre of enlargement, so its image is going to be 3 times 2, which is 6 units above, so 1, 2, 3, 4, 5, 6 is going to be there. Finally, this last point is kind of 1 unit below and 3 along from the centre, so multiplying that by a factor of 2 and it appearing on the opposite side, it's going to be 2 above and 6 along. It's going to be there. So then again, joining my shape together, my final shape is here. Question 15. A triangle has vertices at A, which is 2, 1, B, which is 3, 4, and C, which is 6, 1. The triangle is reflected. Points A and C do not move. Circle the equation of the line of reflection. Okay, now it doesn't say so here, but a quick sketch could be quite helpful here. So if I just draw some axes, that's X and Y, so 2, 1, 2 along 1 up is about there, isn't it? A is 2, 1, B, 3 along 4 up, so up there somewhere. This is just a sketch, it doesn't need to have to be super accurate. And then C, 6 along and 1 up, so that's going to be C there, which was 6, 1. So the points AC don't move, so they're going to have to lie on the mirror line then, aren't they? So my mirror line is going to be here. And my original triangle is then going to be reflected in that mirror line down here somewhere. So we just need to say what the equation of this mirror line is. Right, it's a horizontal line, so it has an equation y is equal to something, and that something is this value here where it passes through the y-axis, and it passes through the y-axis at 1. So the solution is, or the equation is, y equals 1. Question 28a. Here is a triangle ABC. You can see we've been given the coordinates of those 3 points. Describe fully a single transformation of the triangle for which all the points on B are invariant and there are no other invariant points. Now, invariant is a mathematical way of saying that it doesn't change. So the points B and C are going to be unchanged. And the other part says there are no other invariant points. That means that B and C are going to stay where they are and A must move. Okay, so what transformations do we know which will keep this point and therefore that line the same? Okay, well, a simple way of doing it then would be a reflection in that line, wouldn't it? If we make that line a line of reflection, then our image triangle will be down here. So B dash and C dash would lie on their points and A dash would move down here. So that seems to work. So B and C are invariant, they haven't changed, and A has changed, so it's not invariant. So describe fully a single transformation. So how can I describe this transformation? Well, it's a reflection, and I need to give the mirror line. Now this line is the line y is equal to 1. So a reflection, a reflection in the line y is equal to 1. Okay, part B, here is an L shape, PQRSTU. There it is. Describe fully a single transformation of the L shape for which only one vertex is invariant. The line joining P and Q remains vertical, and the area of the L shape does not change. Okay, well, if the area doesn't change, that rules out enlargement, but it could be a rotation, a reflection, or a translation. The line joining PQ remains vertical. Now it only says that the line joining P and Q must remain vertical. It doesn't mean it doesn't switch around. So we could do a reflection. However, if we reflected it along this line, Q and R would be invariant, and I'm only allowed to have one point that is invariant, and similarly any other point of reflection that I do. So I'm going to rule out reflection. Translation would move all the points, so that's not going to work. I think the only way I can do this is using a rotation. Now a 90 or a minus 90, 90 degrees clockwise or anti-clockwise isn't going to work, because P and Q will change direction. It won't be vertical anymore, it'll be horizontal. So I'm going to use a rotation of 180 degrees around one of the points of the shape. That should do the trick. Let's pick this point here, Q. So if I rotate the shape 180 degrees around my axes, it's going to end up looking like this. So that would be Q dash, so that would be invariant. R dash would be over here. P dash would be down here. What's that? S dash and T dash and U dash. So we can see that Q and P do remain vertical, although they're inverted. The area is the same, and only one vertex has been unchanged, and that's Q. So that seems to work. So that was a rotation 180 degrees about, which point was it? About Q, which is 1, 1. Oops. Normally we'd have to give a direction clockwise or anti-clockwise, but 180 degrees doesn't really matter which way around you go. 21a. The diagram shows rectangles A and B. Yes, it does. And underneath it says rectangle A can be mapped to rectangle B by a single transformation. Javed says the only single transformation is a reflection in the y-axis because the rectangles are on opposite sides of the y-axis. So is that the only way that you could move A onto B? Well, yeah, it could be a reflection, but it could be all sorts of other things as well. It could actually be an enlargement scale factor of 1 or -1, sorry, so the image forms on the opposite side of the center enlargement, so that would work. Or it could be a rotation. It could be a rotation about this point here. So it could either be an enlargement scale factor -1 through that point or a rotation through that point. Either way, you would get A onto B. So he is not correct. So either one of those is given. So it could be. So it could also be a rotation, center. What was the center point? 0, 2.5 of 180 degrees. Don't have to give a direction when it's 180, or like I say, it could be an enlargement as well, but one is enough. Question 21b. This diagram shows triangles CDE and PQR. There they are. And we're told that CDE is mapped to PQR by combining two single transformations. The first is a rotation of 90 degrees anti-clockwise about E. Describe the second transformation. Okay, so it's going to be some sort of enlargement or with a fractional scale factor after that. But before we can do or work out the details of where the center of enlargement is, we probably best need to find where that mid triangle is going to be, the one that's halfway between them. So let's carry out this first transformation. That's a 90 degrees anti-clockwise about E. 90 degrees anti-clockwise about E. We're starting with CDE, aren't we? So 90 degrees anti-clockwise about this point here. That means my triangle is going to be, well, the point D is going to end up here. So that's going to be D dash. And C is going to be down there. That's going to be C dash. So we're going to have a triangle here. Okay. And then it ends up there. So what sort of enlargement is that? Well, let's put array lines on. Okay, so joining those 2 points together, we're just matching pairs of points on the object and image together. We should find that they meet in one place, which they do. You can see that they're converging. Oops. On that point there. So that's going to be my center of enlargement, that point at -1, 0. Okay, so it's going to be an enlargement. It's going to be centered on -1, 0. Now what's the scale factor? Now you can see that this side here, the shorter side of my triangle, is 2 in the original image, in the original object, and in the image it's 4, so it's twice as big, but it's also on the opposite side of the center enlargement, so it's going to be a negative enlargement. So it's going to be scale factor of -2. Question 26a. A sketch of a quadrilateral ABCD is shown, and we're told that ABCD is enlarged, center B, scale factor 1/3. So you know that an enlargement with a scale factor 1/3 is actually going to shrink my shape rather than grow it or enlarge it. It's going to actually get smaller. And if this is the center of enlargement, then all the points are going to be 1/3 of the distance away from where they were to start with. So you can end up with a shape that looks a bit like this, kind of a smaller version of itself. B line on the center of enlargement will be unmoved, so that is the invariant point. Invariant means it doesn't change. So circle the vertex that is invariant. That has got to be B. Now there are quite a few multiple choice questions in the exam, and even if you don't know what the answer is, you might be able to rule out one or two of the answers, and then you can just make sure you guess between them. Don't leave any of these unmarked. You've got a good chance of just guessing it right even if you don't know the answer. Okay, 26b, a sketch of the quadrilateral PQRS is shown. PQRS is reflected in the line y is equal to x. Circle the vertex that is invariant. Now let's just draw on the line of reflection. So it's going to go through the origin and it's going to go through that point 1, 1, then, isn't it? Because it's the diagonal y is equal to x. It's that line there. So if I draw that line on, I think you can see what will happen. So it's going to look a bit like that, isn't it? So anyway, the point that is not going to move is this point P that lies on the mirror line. So circle the vertex that is invariant. Again, that's going to be P. Question 7. Describe fully the single transformation that maps triangle A onto triangle B. Now B is an equal version of triangle A, so it's an enlargement with a fractional scale factor because it's got smaller rather than bigger. Now notice this question is worth 3 marks. We need to give 3 pieces of information in order to get all the marks for this question. Now the first mark you'll get from just writing down the type of transformation is. So just writing down the word enlargement will get us the first mark. The next 2 pieces of information I'm going to get is for the marks I'm going to get for the scale factor and for the center of enlargement. Now to work out the scale factor, you just need to find 2 similar sides, or 2 matching sides on your shape, and then divide one by the other. So if you look from here to here, it's 1, 2, 3, 4, 5, 6 squares, whereas this one is 2. So the scale factor then is going to be 2 divided by 6, or 1/3. So scale factor 1/3. And center of enlargement you can find using ray lines if it's not obvious. So find pairs of matching points on your object and image and draw a line through them. So there's one. There's my first ray line. Tops of the triangles. Tops of the triangles are here. Second ray line, and there's another one here. 2's normally enough, but let's just do 1 for luck. You'll find that they all kind of converge on one point, and that will be your center. So here, that's the center of enlargement there. So for the final mark, we just need to mention where the center is. So center, what's the coordinates of that? 5, 1. So enlargement scale factor 1/3, center 5, 1. 3 marks. Question 21. Enlarge triangle ABC by scale factor of -2, center 4, 1. Okay, so the triangle's already drawn and the center of enlargement is also drawn. What we need to do is find the image points of A, B, and C. Now, when you've got a negative scale factor, your object and image are going to appear on opposite sides of the center of enlargement. Now, it might be handy to draw ray lines on. So ray lines are lines that pass from each of your points through the center enlargement and then out to your image points. So there's my first ray line. That's my next one. Kind of like guidelines. And then finally, 1 through B in the center. Okay. Right, so let's take each point in turn. So my centre of enlargement is here. It's got a bit obscured by my lines. Then my point A is here, which is 1, 2, 3, 4 units to the right of my centre of enlargement. Okay, and I'm going to multiply that by a scale factor of -2, which means that it needs to be -8 units from that centre, or 8 units the other way. So counting 8 units in the opposite direction, 1, 2, 3, 4, 5, 6, 7, 8, it ends up there. So that is going to be my point A dash. Okay, so that's A dash. So we're going to do the same thing with B and C. Now if you look at B, B is kind of 1 unit below and 2 units to the right of the centre of enlargement. So I'm going to multiply that by a scale factor of -2. So rather than being 2 below, it's going to be 2 times 2, 4 above. So it's going to be 4 units up from the centre of enlargement. And rather than being 2 units to the right, it's going to be 4 units to the left. And you should find it lands on one of your ray lines. So that point there is my point B dash. Okay, and then C, the same thing. That is 2 units below and 3 units to the right. So multiplying that by a scale factor of -2, it's going to be 4 units above and 6 units to the left. 2, 4, 6 puts it here. Again, it should fall on one of your ray lines. That is C dash. Okay, once you've got your shape, you can join up with a ruler. Okay, all done. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.